as I hinted, and you saw a tiny preview up in the last video, we're next going to be talking about the structure of the code. Now, this is a really quick and early intro to the exercise for trees that we're going to be working on. We're going to be building a tree. We're going to be building specifically a tree set. And this is going to be an important differentiation because in the book, it talks about keys and values. And that's important when we talk about tree map implementations. But since I want to start simple, keep it a little bit easy. It's not the end of the world to build trees more than once. So we're actually going to just deal with individual values, no key and values. And so we're going to talk about a tree set, which means our node structure, instead of having to have a key and value, we just have a value. The value is the key in a set. And again, we have a left and right as we saw, and then there's just a little constructor here to build the node. But that's this internal node structure. So as we're talking about the tree set, like the list, we're going to get its size. We're going to see if it's empty. And then it's going to be some important, notice it's a smaller list here. So size, list, empty, size is empty, clear are the same. We can add or remove from the set. And then there's some behavior to see if the set contains a specific value. And then I think it's useful to be able to convert these to vectors to be able to print out what's in them. If you aren't one to watch all the videos, you happen to be watching this one, the vector one is going to show up. We're going to build it together in one of the upcoming videos just to make sure you have that right because it's super useful in debugging, assuming you're building your tree usefully. But notice now in this set, I am giving you exactly what I want the node to look like. I'm actually even giving you the helper functions, the recursive helper functions that really kind of focus in on these algorithms. So we had practice within recursion. We had practice in building data structures with the list. Now we're going to really focus on the algorithms involved in the trees because it's a complicated structure. So by the way, just pointing out, class node here is a placeholder so I can put the node down below. All this is saying that there is a class node that's going to be defined down below, but I wanted to hide the class down below so it's easy to find. Our tree set structure then is just simply a root node, and I'm tracking the size of the tree as an integer, so I don't have to traverse it every time for the size. So this is the structure I'm giving you. Now, just to show you a little bit about this, I can run this code right now. It has testers, and the testers are a little bit different. So the tester here is ordered. So you need to do add/size first. So you get add/size working before you can work on any of the other ones. Now we're gonna again build the vec2 vector, turning a tree into a vector so we can print it out. We're going to build that as a test together, but I'm going to cheat and I'm going to slip in my solution for the add node so we can get to that more quickly. But that's going to show up here in a little bit. But when we run it, we're going to have that. And so if we go to the test cases, there's going to be a bunch of test cases, including an ability to turn your vector into a string and some stuff if you need to use that in different test areas. But notice actually, I'm going to reorder this now that I look at this. This is going to move up one, but these are going to be sequenced. So you test one, then the other, then the other. And so you're going to do them in an order. So let me just show you. I'm going to do this here in a minute. This wasn't the order I built them in, but then once I built this, I realized how useful that was in sorting out the tree beforehand. I did it by hand, but maybe this is something that's going to be useful for you. The other little bit of trickery that's in this test case, I have it randomly generating inputs each time. And if you want to see what got added, then you can flip debug to be true. There's a Boolean up top here, flip debug to be true. And when debug is true, it will print out each of the characters. It's just sorting on characters within a string, single characters. It'll print out each character that's adding one at a time and then a little line in between it so you can see what's being added. If you ever want to test with something specific, you can always change this fill sets test case to put hard code something within a set going forward. If you want it to add A, B, C, D, E, you can just have this right here loop over, and instead of randomly selecting it, set an array and add A, B, C, D, E. So I want you to see a little bit of the structure of the test case so you can manipulate it. But the add test case also generates random characters. So just be aware that if you want a specific order for add, in the add test case, you'll have to modify it here as well. All right, so we'll get more to this code in a little bit. But I do want you to see right away that the images we saw in the slides before, so if I bring the slides back up, especially when we come right up here, this node, value left, right, that shows up exactly in the code, value left, right. We're going to keep it simple. The book does have the key and value, and you're welcome to play with key and value at some point. But for now, the key is the value, so I'm not even adding the key in here. That's something you can choose to add later on. Maybe it'll be an exercise to add it later on. I don't know. We'll see. But I want you to just deal with a simple traversing lists, adding lists, removing things. That's where we're starting with for now. All right. So let's dive a little bit more into the concepts. But at least you've seen a little bit of code and you know where this is going.